Hello everyone, welcome to the class, and in today's class we are only going to be solving few numericals. So till today's class we have learned some concepts from electric fields and charges, right? We have learned what is an electric charge, what is an electrostatic force, what is an electric field. We have also done continuous charge distribution, superposition principle. So applying all of those, we will do some numericals. Okay. Today evening at 8 p.m. there is another class. In that class I will discuss about dipoles and electric lines of forces. But this class is completely going to be numericals. Any doubts, since it's just a numerical class, any doubts you have, you can ask me. Alright, and let's go ahead. My name is Mohana. I'm a physics educator here at Unacademy. I'll be taking your class 11 and 12 physics, and this is my link to my Telegram channel, so you can follow me for any updates. Before going live, I'll be sharing the class link in the Telegram group. Any other updates that's there will also be shared in this group. We also have a common Telegram channel link for both ICSE and ISC both, so you can follow this channel as well. Now, just like how we have our free classes on YouTube, we also have some special classes in the Unacademy website itself. Right? These classes are absolutely free. You can take from any of your favorite educators, and any topics you're learning. We have an interesting features which is pools, so you can answer questions that you're learning on the pool, or anything else, any other questions also in quiz types. The sessions would be mostly held in quiz types, and you can answer questions through your pool feature. Okay, and since these are again live classes, any doubts you have, you can get them cleared then and there. Now, the upcoming session, special classes session for class 12, I would be sharing it in the future classes. And other than the plus free classes, we also have plus subscriptions. Now, in plus classes, we will be basically, you can basically take these classes, since these are online classes, you can take them at the comfort from your home. And you also have an unlimited access to all courses. Right? And all the educators at Unacademy are good, so you'll be learning from top educators. And we have a doubt class feature, that is every fourth class, once you take a plus subscription, every fourth session would be a doubt clearing session. So in this session, you can actually, whatever topics you've learned, like till now, whatever topics you've learned, if this is, if in your plus class, if this is a doubt session, you can ask any doubts you have regarding those topics you've learned till now. Okay. Now, we will also be covering the entire syllabus, right? And we also have a special features, that is basically your live test series. This is every weekend. We always have live test series. Right, so you can take the test. So whatever concept you learned, based on that, the test series will be arranged, and you can take the test to assess whether you've understood the concept or not. After every test session, there is an analysis session. So if you got any question wrong, you can ask the educator like how to solve them and clear your doubts then and there. And we have new batches coming up, so do check out. And now the prices for all of the courses that you're taking, right, that depends on the duration in which you're taking, right? If in case you're taking for a course for a longer duration, then the price does come down. And if you're using my code MTIS10, you will be getting a 10% discount on any plus subscription you're taking. Okay. Other than this, you can use this code to also access the free special classes that are there, okay, in the Unacademy platform as well. Now, we have the Unacademy Unset is basically going to start soon, right? This is your Unacademy National Scholarship Admission Test. So this test is going to be Alok. This test is basically going to be an offline test for your IIT, JEE, NEET, UG and class 9 and 10, right? Especially foundation courses, right? These tests is basically for preparing for these classes, right? So the test is going to be held on 4th to 5th, okay? You can, again, the test, whatever the test price is around 199 rupees. But if you're using my code MTIS10, you'll be getting a 10% discount on that. The last day to register is on June 3rd, right? And this test is going to be a computer-based test, but it will be in the offline centers. Okay, if in case you can get up to 90% scholarship if you're taking these tests, right, for your IIT JEE and NEET UG, right, and also for your class 9 and 10 fundamental courses preparation. If in case if you're taking this if you're taking these tests, and if you're getting if you're coming in the top, right, if you're coming in the top ranks, you can actually get up to 90%. There will be some scholarship given depending on your ranking, but you can get up to 90% scholarships. Okay, and the top 40 rankers will also get an iPhone. Okay, and test takers get an Unacademy t-shirt as well. Alright, so do check out the you can just go check, the link will usually be in the description, in the chat box. If not, if you just type UNSAT Unacademy, you'll be getting it. The last date for registration is June 2nd, and June 4th to 5th would be your exam time. Mostly multiple choice questions. So the syllabus for the same can also be shared. In case if you want to know what would be the syllabus, let me know. Now from the previous class onwards, we have started doing Alok, I am fine, thank you. How are you? And we have started doing we basically started with this unit of electrostatics, right? In electrostatic, we started with what is Coulomb's law. So basically, very simple. Since we are doing numericals, I am basically giving the equation, a very simple short form equation of all of these charges. If there are two charges, right, let's say this charge is Q1, Q2. These are point charges and these charges are at rest. Okay, and if the distance between them is R, okay, then the force acting between these two charges is given by the Coulomb's electrostatic force equation, right, which is 1 by 4 pi epsilon naught. Epsilon naught talks about the permissivity of the medium into Q1, product of the magnitude of the charges by inverse, and this force is inversely proportional to the square of the distance between them. Okay, now this 1 by 4 pi epsilon naught is basically your constant electrostatic force constant K, and this value is 9 into 10 to the power of 9. Okay, so this is your basic force equation. Okay, remember them, it will come handy as we are solving the questions. Can anyone tell me what is electrostatic field in terms of force and charge? How do we define electrostatic field? Is it force per charge? Is it force times charge? Is it charge per force, or is it none of the above? Electrostatic force is force per charge. That's right, Alok. Electrostatic field is basically force per charge. That is right. So your electric field is defined as if in case you have a test charge, this is your source charge, and let's say this charge has an electric field lines in this direction, right? Now, if I introduce a test charge anywhere over here, let's say this has a field here, anywhere over here, and let's say my test charge is Q0, okay? And let's say this charge is Q. Now, this test charge is always positive unless otherwise is said. Its test charges are always positive. Now, this test charge will experience a force in this direction. Okay, it is getting repelled. In this case, it will experience a force in this direction. So, your electric field is always force per charge. Okay, so from here we know the force equation, right? It will be 1 by 4 pi epsilon naught Q naught divided by the distance between these two. Let's take that as R. From this charge to this charge, let's take the distance between this distance as R. Okay, R square. From there, the whole of this equation divided by Q naught, right? From here we get the electrostatic field is nothing but 1 by 4 pi epsilon naught Q by R square. From here we can actually find out what is the electrostatic field. What is the electrostatic field around this particular source charge? Right, this is your electrostatic field equation. And what is the unit of your electrostatic field? What would be the unit of electrostatic field? What would be the field in units? So over here, if you see, electric field is given by force per charge. Unit of force is Newton per charge. So this is Newton per Coulomb, or this is Newton per Coulomb. This is your unit of electrostatic field. Now, so again it is a vector quantity, and it's the electrostatic field is Newton per Coulomb. So whatever questions we are going to solve today, it's taken from your reference books. That is your Newton, right? Your ISC physics, Newton. I'm taken only those questions from Newton, and also from your reference books, right? Like New Simplified Physics by S.L. Arora. These are where I've taken all the questions from. So let's try solving some of these. Okay. Let's do a very simple one. So you had already done about, we have already discussed about charges, right? So, okay. Let's do a very simple one. We had already done this earlier, but I'll do a different question like than what we have done earlier. Okay. So, if a body gives out, let's say, we have already seen that 1 Coulomb of charge is a very much larger, right? So it's a very large, huge charge, amount of charge. So over here, let's say if a body, okay, gives out 10 to the power of 9 electrons, right, every second. Every second it's giving out 10 to the power of 9 electrons. Okay, then how much time? Time is required okay. Alright, so this question is actually pretty simple. So in case if you're watching the recordings, try to think what are the equations you might need to use for this question. Alright, so if a body gives out 10 to the power of 9 electrons every second, how much time is required to get a total charge of 1 Coulomb from it? 1 Coulomb is an extremely huge value, right? So to do this, first we need to know how much number, okay, the number of electrons it gives out every second. Let's take that n to be 10 to the power of 9. It gives out 10 to the power of 9 electrons every second. Okay, now what will be the charge if it gives out 10 to the power of 9 electrons in 1 second? What will be the charge? What will be the charge given out by the body in 1 second? Charge that is given out by the body in 1 second. In 1 second, what will be the charge given out? Now this charge, we know you can use the equation Q is equal to N into E, right? E value is already known. E is basically nothing but 1.6 into 10 to the power of minus 19 coulombs is E, right? So from here, if you want to calculate how much charge that particular body gives out in 1 second, okay? We know how many electrons it gives out in 1 second. Now we want to find how much charge it gives out in 1 second. So that is equal to Q is equal to NE, your quantization formula. So here, quantization of charge, right? We use that equation. So Q is equal to N is what? 10 to the power of 9 into 1.6 into 10 to the power of minus 19 coulombs. So in case if you're solving, just share. If you solve before me, share your answers in the chat box. All right. So this is equal to this charge, the total charge it gives out in just 1 second. This is equal to 1.6 into 10 to the power of minus 10 seconds. Okay. Now, what is the time required, okay, to get a charge of 1.6 into 10 to the power of minus 10 seconds? What was the time required? 1 second. Okay. Now, in 1 second, we are getting a charge equivalent of 1.6 into 10 to the power of minus 10 coulombs. Okay. Now, if we want to get the total charge of 1 coulombs, what will be the time required? Time required to acquire, okay, 1 Coulomb of charge. Okay, this would basically be in this case for for time required to get a charge. So much charge if you want, right? Time required to get this much amount of charge is basically 1 second. Now time required to get 1 coulomb of charge will be 1 divided by 1.6 into 10 to the power of minus 10 coulombs. It's minus 10 seconds. Okay, this is nothing but 1 divided by this value, because 1 coulombs, right? So here 1 divided by this particular value will give you will basically give you how much time it requires, how much time required to get a charge of 1 coulomb. So this basically will give 6.25 into 10 to the power of 9 seconds. Okay, now the answer is in seconds. Let's try converting them into years, right? So here 10 to the power of 9 second means 6.25 into 10 to the power of 9. This in terms of seconds, right? This is basically in seconds. If you want it in years, that will be divide the seconds by 365 days, and every day has 24 hours, and every hour has 60 minutes, and every minute has 60 seconds. Right? If you solve for this, you will get 198, around 198.2 years. Okay, thus for a body to emit 10 to the power of 9 electrons, if it is emitting 10 to the power of 9 electrons, every second, per second it's emitting 10 to the power of 9 electron. Okay, then it will nearly take 198 years. 198 years is almost close to 200 years to get a charge of 1 coulomb from that particular body. So this basically shows how large 1 coulomb of charge is. Okay, right. So from here, let's see. Okay, from here, let's see. Okay. Let's go into the next question. Okay, now let's see, let's calculate force. What will be the force? Okay, so let's say we are given two small charges. Okay, let's say charge Q1, that is one charge, right? This has a particular charge 2 into 10 to the power of minus 7 coulombs. Let's say there is one charge, this is Q1, and we don't know what, okay, this is a point charge, so we don't know what this charge is, but we know it's a point charge. We know this is a point charge Q1, and Q1 has 2 into 10 to the power of minus 7 coulombs. Now let's take Q2, right? There's another charge. This is 3 into 10 to the power of minus 7 coulombs. Okay, this is basically Q2. Now these two charges are separated by a distance, right? The distance that they are separated, let's give it by R. Okay, now this R is basically given as 30 centimeters. Okay, and now the entire system is kept in air. Okay, two charges, one has a charge 2 into 10 to the power of minus 7 coulombs, another has a charge 3 into 10 to the power of minus 7 coulombs, and they are separated by a distance of 30 centimeters, and they are kept in air. Alright, so knowing this, what will be the force? What will be the force acting on them? You can solve the questions. If you solve it before me, share it in the chat box. Alright, I'll start solving. To find the force, it's very simple, right? Force is basically given by electrostatic force is given by Coulomb's law, which is basically 1 by 4 pi epsilon naught Q1 Q2 divided by R square. 1 by 4 pi epsilon naught value is basically known for air. The value is known. This is 9 into 10 to the power of 9 newtons into what is Q1? Q1 is given over here, 2 into 10 to the power of minus 7 coulombs. And Q2 is also given over here, which is basically 3 into 10 to the power of minus 7 coulombs. The whole of this, right, we are going to divide the whole of this by R, right? But R value that you're seeing over here is in centimeters. We want to convert it into meters. So centimeters to meters, if you convert, what will be the value of R? So R is basically going to be around 0.3 in terms of 0.3 meters. So you can write the same here. So here R is going to be 0.3 meters, but here it is r square. So if you solve for this equation, okay, so 0.3, this is this becomes 0.9, right? So 3 and 3, okay, so this you can write it as 3 into 10 to the power of minus 1, right? And you can take it up, and if you solve for this, you would, why, Ramat, are you asking why r is in meters? Okay, so any fundamental quantities that you're taking, you have to give them in terms of the SI system of units, right? Right, so according to that, in SI system of units, basically the answers are usually given in terms of meters. So any conversion that you're doing, right, from centimeters, if the question is asked in, you have to change it to meters. And if the question somewhere mass is given, and if the mass is around given in grams, you have to convert it into kilograms. And does that solve your answer? Does it answer your question? Okay, now anybody who has solved this question, you can give me the answer. So the answer for this question is going to be 6 into 10 to the power of minus 3 newtons. Alright, so anytime you are writing, right, anytime you're solving the numericals, do not forget your the units. The units from mostly, unless and otherwise it is specified, the units, so we are always giving in terms of the fundamental basic units only. That is the SI system of units. So we always give measurements in terms for mass in kilograms, meter, length, distance in always in meters, time we give it in seconds. Sometimes the question asks in hours or minutes, depending on the questions we change. But if it is not mentioned, especially for mass and for length, if it is not mentioned, give it in terms of kilograms or in terms of meters. Okay. And also in this force equation, when you're saying it is so much Newton, the force over here, the fundamental unit that you're taking into terms over here, right, when you're calculating this force, this is actually in meters. Alright, okay. Now we've done 2 questions. Now let's do a question based on the point charges. Okay, let's use superposition principle. Okay, let's say there are 4 charges. Let's say there's 4 charges. There's a charge here. Let's say there is one more charge over here. There are 4 charges. Okay, the 4-point charges. Let this be charge QA, right? Let this be charge QA. Let this be AB. Alright, C and D. Okay, these are actually located in the 4 sides of a square. 4 charges are located at the 4 sides of the square. Okay, let's say the charge over here, this is basically given as QA, and this charge over here has a particular QA. I'll write the value of QA is basically equal to 2 coulombs, 2 microcoulombs. 1 coulomb of charge is too high, so we always use a smaller unit, that is basically 2 that would basically be around in microcoulombs. Micro over here, the micro value that I'm using, right, mu actually, the value of mu is nothing but 10 to the power of minus 6 meters. Okay, coulombs. In this case, mu means 10 to the power of, the value is 10 to the power of minus 6 micro. So coulombs, whenever you're talking about charge, we always give it in terms of microcoulombs, okay, because 1 coulomb of charge, as we saw earlier, is a very huge charge. Now, there's one more charge over here that is in B. Let's say the charge is QB, right? And this charge has a value of minus 5 microcoulombs. So this is a positive charge, QB. Over here, this is a negative charge. There's another charge over here. Let's say this charge is basically QC, right? And this charge is again over here, this one is again minus 5 microcoulombs. Again, same amount of charge is there in this vertex, vertex D. Okay, now let's take this charge QC. The charge on this vertex over here, right? right, QC, this vertex right over here, the charge on them, right, is basically around 2 microcoulombs again. There is a positive charge placed here, right? The charge value in this case is around okay, the charge value over here is around 2 microcoulombs. Over here again, the charge value is again 2 microcoulombs. But we look at the charge over here. This one has a charge of minus 5 microcoulombs and this one has a charge around minus 5 microcoulombs again. Okay, so we know what is the coulombs. And each of the charges, right, each of the charges is basically kept 10 centimeters apart. So the side length of all of the sides, right, 10 centimeter. Each of the charges are kept 10 centimeters apart. Okay, so now we know there are 4 charges. We know the separation between them. Now, if you introduce a test charge in the middle, if you introduce a test charge in the middle, and the test charge that you're introducing, right, this test charge that you're introducing, let's keep the test charge as Q0. This has a value of 1 microcoulomb, right? This test charge has a value of 1 microcoulomb, okay? Because we want to study what is the field in this particular point. What is the electric force acting at this particular point due to these 4 charges. This is based on your superposition principle. If you want to study anywhere, if you want to study a force or a field at a particular point, what do? We always introduce a test charge. So the test charge has a value of 1 microcoulomb. Okay. Now, what will be the force acting on this charge of 1 microcoulomb that is at the center because of all of these 4 charges? Because of these 4 charges, what will be the force acting on the center? Anybody who could tell me what will be the force? Or if you feel that you can at least think of few steps like how to solve the question, you can tell me. You can use the chat box to give the answer. What is the difference between a test charge and a point charge? Point charges, basically we say they exist at that particular point alone. We do not take if you point charges, we do not consider the mass. It can be a huge sphere, but still we are going to say that just exists as a point. One of the dimensions of the charge we do not take into consideration alone. They just exist at that particular point is what we say. Okay, and so test charges are charges which are, let's say I have my source charge over here. This is a positive charge. Okay, now I want to study something about this charge. Maybe what is the force that is acted because of this charge, or what are the field lines. Okay, if this charge has a field line, okay, anywhere I want to study anything about a particular source charge, what we would do is we introduce a test charge. Test charges are charges which has very small mass. Okay, and they are usually taken as positive charges. Now, because of a test charge, when you introduce this charge, let's say this positive charge has so many field lines. Now, I want to study this place if there is an electric field that is there or not. What would I do? I will introduce a test charge. But the property of the test charge should be such that the field generated, the mass of it has to be very small, because of which the field the test charge generates itself will be negligible. So, the test charge does not disturb any of the surroundings. The properties of the test charge shouldn't disturb any of the surroundings. So the test charge is going to be act as if you're just using that to study some property of this particular source charge. Now if the test charge, if you place it here, test charges are positive, this is also positive, it will repel it in this direction. So if this test charge gets repelled in this direction, what do you mean? We can say, okay, there is some sort of a field that is acting around this positive charge. That is why this charge, when I place it, it is getting repelled. It is experiencing some sort of a force. Okay, does that answer the question? So test charges are usually used to study some property of the field or the force that exists, and they should have very small mass, and they shouldn't disturb the system into which they are introduced into. Okay, so in this case, to study this, right, let's see what is the force experienced by this charge. Okay, now let me just draw a small diagonal connecting all of these 4 charges. Okay, now First thing, what will be the force acting on this charge, right? What will be the force acting on? See, this is a positive force, right? This is a positive charge. This is a positive charge. Now, what will be the force experienced by this 1 coulomb of charge because of this 2 coulombs of charge? Now, these two charges are like charges, so it will repel. So, this charge QC will repel this charge over here in this direction. Okay, so this is because of the charge that is placed on this vertex C. Similarly, think what about this charge? This is basically a 2 coulombs, microcoulombs of charge, and this is 1 microcoulomb. So both are positive charges. What will be the direction in which the force will experience? So now this charge will experience a force again in this direction. So because of this charge, this charge will experience a force in this downward direction. This is because of the force experience on the 1 microcoulomb of charge because of the 2 microcoulomb charge that is placed at E. Okay. Now, on one side, there are 2 equal and opposite forces acting, because if you see the magnitude, if you calculate what is the force on this test charge because of the charge that is kept at A, this will basically be what? 1 by 4 pi epsilon naught, right? 1 by 4 pi epsilon naught. QA also experiences force of QB, right? Correct. Now 1 by 4 pi epsilon naught, this will be this test charge that is kept over here, that is Q naught into QA divided by R square, right? Similarly, if you look at the force because of the charge that is kept at C, it will be 1 by 4 pi epsilon naught Q1 Q naught Q C divided by R square, right? If you look at all of these charges everywhere around, right, the magnitude remains the same. If I substitute the value 1 by 4 pi epsilon naught, we know what is Q naught, right? Q naught is given. QA we know. If we calculate this distance over here, that distance is equal to this distance because this charge is kept at the midpoint. So R square, everywhere in this equation, both the magnitude will remain the same. Okay, magnitude remains the same, but direction is opposite. So there is equal forces acting in opposite direction. What will happen to the force acting at this point over here? Magnitude is same, but the direction of the force is different. So the force acting on this charge because of the force on QA will cancel out the force created because of this FC. Right. Similarly, if you do look at the other side, right, the other two charges. Now, because of this charge, right, this is a minus by Coulomb charge. This is a 1 Coulomb charge. So opposite charges will always attract, right? The force will be in this direction. Okay. So here, this is the attractive force because of this force over here at this place. And over here, this is also minus pi Coulomb of charge. This is also 1 Coulomb of charge. Now, this will attract it in this direction. Okay, this charge will experience a force of attraction in this direction. Again, these two cases also, magnitude same. If you calculate substitute for the magnitude equation, in these two cases also magnitude is same, but the direction in which the force is acting is different. So what will be the total force acting at this point F? The total in the central point, the total force experienced by this test charge will be basically because of force due to A plus force according to superposition principle, force due to B, force due to C, and force due to this charge T. But we know the force on A is equal to the force force A, right? FA is equal to FC, the force of here experienced by this charge because of this charge C. They are the same, but they are in the opposite direction. Similarly, we know FB, right? This force is basically equal to this force, but they are again in the opposite direction. So from here, we can say, if you substitute for this, what will we get F as? Their forces equal magnitude but acting in opposite direction. So the total force experienced by the charge of 1 microcoulomb of charge in the center would be 0. Clear? This is the answer to your question. Any doubts? All right. If you have any doubts, you can ask me in the chat box. Okay, otherwise I would go ahead with the questions. Okay, how about we do one question based on electric field? So one question based on electric field, and we can, I think by then if you have any doubts, in the meanwhile, if you have any doubts regarding electric field, what is electrostatic force, electric field, you can take this class, right? You can ask me any doubts you have in any of the topics we have covered in this class now. Okay, similar time. Let's do one more question. Okay, I'm going to do one more question. This time, let's do this charge. Let's say we have a square. Let's say we have a square, and let's name the vertices A. Right? This A, B, C, D. Right? Similar to the previous question. Okay. Now let's say the sides of each of the square, right? The sides of each of the square is around 5 meters. Okay, each of the side is 5 meters. Now we are keeping 4 charges, right? We are keeping 4 charges on each of the vertices, right? So there is a charge over here, and this charge is around plus 50 coulombs. That's a huge amount of charge. Okay, and over here also we have a plus 50 coulomb of charge. Okay, now we have another charge. Okay, and at let's say at another end, okay, over here, right at here, let's say the charge that is placed in this place is minus 50 coulombs. That's 1 coulomb of charge is too high, so 50 coulombs is a very high, the charge value is too high. All right, now if this is minus 50 coulombs, now we want to find what would be the charge, at this point B over here. Okay, this is where we want to find what will be the electric field. Okay, we want to find the resultant. Okay, there are 3. This is again based on superposition principle. 3 charges, right? 3 charges. Okay, because of the 3 charges on this point B, what will be the charge? What will be the electric field? What will be the resultant electric field? That's what we want to find. Okay, so electric field. Let's see the first point. Let's do the easy one first. Okay, so if you're actually finding the electric field lines because of this charge, right? So because of the first one, so here electric field at B because of this charge A, right? Let's take that as EA. What will be the field? The field would be, electric field will be constant K has a value 1 by 4 pi epsilon naught. Okay, so I'm just going to keep K as it is, right? And electric field is given by 1 by 4 pi epsilon naught Q divided by R square. Right, so over here what is the charge Q? Charge Q over here is 50. Okay, because of this 50 coulombs of charge which is kept 5 meters apart, what is this force at B? Okay, if you calculate this, 5 square is 25, right? 5 square is basically 25. So 50 by 25 will give us 2. Right, will give us 2. So this EA gives us 2K. K is basically 1 by 4 pi epsilon naught. 1 by 4 pi epsilon naught is basically the charge values 9 into 10 to the power of 9. Now what is the direction of this field? This will be along AB. Okay, now this field will be in this direction because of this force. This field, at this point, the direction, the resultant, this is a positive charge, right? It will emit. So this force will be in this direction. Okay, this is your force because of the first one, that is EA, right? The force is in this direction. Alright, now what will be the force at B because of the minus 50 coulombs of charge? This is also easy, right? Now the force at B, right, electric field at this point B because of this minus 50 coulombs of charge, right? So for that I'll mention that as EC. This will be what? Again K, Q divided by R square. K is there, Q is what? Okay, 50. But in this term, what? So in this case, this will be 50 coulombs. We are just taking the magnitude over here. 50 minus 50 coulombs means it is a negative charge, right? It is a basically we're talking about an electron. Plus 50 means it will be a positive charge. It's a proton. Okay. So here 50 divided by again 5 square. 5 square is again 25. So basically here also you will get, right, 2K. Now this force will act along CD. From C, will act along BC, right? This force will basically act along BC. Why? The electric field lines for negative charges are always inwards. Since it's a negative charge, the electric field lines will flow inwards, right? So from there, in this case, the electric field lines are basically coming down this side. Okay, so this will be EC. Okay, now the next one is what will be the field because of this charge, this plus positive, right? This charge over here. Now this ED, if you want to find, that will be KQ divided by R square. But how do we get the distance? Right, how do we get the distance? To do that, we have to find this. You have to consider this as a triangle. We know this is 5 meters, this is 5 meters. What will be the distance in this case? Right, so this is Pythagoras theorem you would be using. So according to Pythagoras theorem, if you want the hypotenuse, that is nothing but square of these two values. Hypotenuse square is basically your opposite by adjacent. Opposite by adjacent is what? 5 square, right? In this case it will be 5 square plus 5 square, 5 square plus 5 square. So this is your hypotenuse, right? Now if I want hypotenuse square, if I want the hypotenuse in this way, it will be square root of 5 square plus 5 square, right? So h, this distance over here, right? This distance over here is going to be 5 square plus 5 square, that is going to be root 50. So over here, this is basically the diagonal value is root 50 meters. Okay, so here we can substitute the same in this equation. So you will basically be getting Q divided by R square, right? So over here you have K. What is Q over here? 50 again divided by root 50, right? This will give you root 50 the whole square. So this will give you the value K, but this time this is along dB. This is along dB. Now this force is along this way. This is basically your electric field along this because of this charge D. Now you have 3 electric field lines acting at this point, right? So you have to find the resultant. Okay, you actually have to find the components. Now, so if you want to find the resultant, right, you will basically have your X component and Y components in each of these cases. Because if you want to find the resultant, then you'll have to look at what are the forces, the component of each of these electric fields along the X axis and along the Y axis. Okay, so to do that, let's take component of the first one, right? In the first case, okay, so let me get some space to do this. Okay. You have 4 charges, right? So one was around so you have a force acting in this direction, you have a force acting in this direction, and you have a force acting downwards as well. Now this is force because of EA is in this direction, EC is in this direction, this is because of ED, right? Now everywhere each of this is 5 meters, around here it is going to be 15 meters. Now the charge on this point is plus 50 coulombs, the charge over here is again plus 50 coulombs, but this is minus, this vertex is minus 50 coulombs. Okay. Now using this information, if you want to calculate the charge, then the component along the for EA, right, for EA, let's look at the x-axis of the component and the y-axis of the component. Okay. Now this component EA is along the x-axis, and we found the value along the what is the force acting on this point P because of this point A, right, that is along the x-axis, right, that we found to be the magnitude was found to be EK. Right. Now if you look at the y-axis, right, if you basically look at the y-axis, this electric field line does not have any component in the y-axis, so that is 0. Now if you look at the component EC, right, EC, now there is no x-axis for EC, right, E2, there's no x-axis, it's only acting, it's not acting along the x-axis, so that's 0. Along the y-axis it has a component, along the y-axis it has a component 2K. Okay. Now comes your component ED, that is this component. Now what about its component along the x and the y axis? To find that, we have to find the angle between them, correct? Now the angle, this is ED. Now if I find the resultant of this one, right, if I want to find the resultant of this one, I'll basically be taking so this is straight, right, this is going diagonal, so this degree, angle of degree over here will be 45 degrees. Okay, so this, if I draw a straight line over here, right, if I'm drawing vertices over here, if you're solving using the vector laws over here, you will get around 45 degrees. Okay, the angle over here would be 45 degrees, and this component we have to resolve it into x component and y component, right? So you have one component because of this EA, there is one component that is acting in the x-axis direction, and there is another component that is acting in the y-axis direction. So entire angle 90 degrees, this angle is 45 degrees. What will be the x-axis component? The x-axis component is going to be, in this case we have E into whatever the value that we have gotten, that is ED into cos into if I want this, that will be, if I want this vector over here, this vector, if I want, I have to consider hypotenuse and the adjacent side, that's cos theta, right? So cos theta would give me ED by cos 45. So ED into cos 45. Okay, cos 45 is 1 by 2, right? Similarly, in this side, if I want this component, now this is going to be again in the x direction. No? This again, this angle is 45 degrees, and if I want this, this is going to be ED into cos sin 45. Okay, so cos 45 is 1 by 2, sin 45 is 1 by 2. So if I substitute the value, ED is basically K, right? K into 45 degrees will be 1 by 2, 1 by root 2. Here again this will be K into 1 by root 2. So these are your components, x and the y components. Okay. Now if you look at the component this component over here, right, that you resolved, they are both acting in equal and opposite direction. Okay, so from here we can say, since these two are acting in equal and opposite direction, Okay, since they are acting in equal and opposite direction, this component is acting down, this component is acting up. Since they are acting in equal and opposite direction, so we can actually write okay, so we can actually write this is basically 2k, right? One of the value over here is basically, this is from these components, that the total component along the y-axis, the total component along the y-axis, if you're looking at the total component along the y-axis, that is going to be 2k minus k by root 2. Okay, so now if I want to find what is my total component along the x-axis, now the total component along the x-axis in this case, we have a 2k component going this direction, and if you say there is another component, that is the x component of this one, that is going in this direction again, both of them are going in the same direction. For the x component we will have to add, so this will be 2k plus 0 plus k by root 2. So these are your x component we are adding, these are the y components we are adding. Now if you want the resultant, if we basically want the resultant is because of what? The resultant electric field at B, the resultant electric field at B is basically, in this case, if I want the resultant electric field, now this resultant electric field is, there are two components. Now this component is in the opposite direction, we resolved it into this side and this one, right? This one is in the opposite direction, but if you reverse it, it will get a negative sign. Correct. So from here, I can take the resultant component to act along this direction. This will be my resultant component. The resultant component, because of E, the electric field, because of all of these charges at this point, will be over here. Now this E is because of these two vectors, that is your x component and electric field along the y component. We found electric field along the x component, electric field along the y-axis. Okay, now you just have to take the square of the resultant electric field will be square of these two values, would be square of Ex plus Ey. Okay, now if you take square of these two values, let's do that. Now in this case, if you're basically taking the square of these two values, square of Ex square is what? X is basically this value, right? 2 times, here we can take 2k, right? You can take k outside and you will have 2 plus 1 by root 2, right? The whole square. Okay, plus here also I can take k commonly outside, it will be 2 minus 1 by root 2, the whole square. Okay, so if you solve for this, now this will be 2 root 2 plus 1 by root 2, and this will be again 2 root 2 minus 1 by root 2. So if you are solving for this, you will get E, right, around 9 k square. This will be the total electric field magnitude. Okay, now we know the value of k, right? This the square root of this, right? Square root of this is nothing but 3k. We know the value of k. K is nothing but the electrostatic force constant, which is 1 by 4 pi epsilon naught, and its value is actually 9 into 10 to the power of 9. Value is basically 9 into 10 to the power of 9, right? So if Newton per Coulomb, right? So in this case, if you're substituting for this value, you will, so Newton per Coulomb for electric field, right? So here the electric field, you will be getting the value of the electric field, you will basically be getting at 18. Okay, the value of the electric field E that you will be getting would be around 3 into 10 to the 9, 3 times 9 into 10 to the power of 9. That's around 27 into 10 to the power of 27 into 10 to the power of 9 Newton coulombs per coulombs. In case if you want to write in decimals, this is 2.7 into 10 to the power of 10 Newton coulombs. So this is the resultant electric field. So if you have 4 charges, in this case you have 4 charges, right? And at this point B, the resultant electric field, because of all of these charges were acting in this direction down over here. Okay, and the charge was around 2.7 into 10 to the power of 10 Newton per coulomb. Alright, so with this we are coming towards the end of the session. Right, we also did continuous charge distribution. So continuous charge distribution is very simple. We imagine the charge to be spread out in a continuous manner in region, because usually we deal with the magnitude of the charges that we deal with are always very large. Okay, and there are three types of continuous charge distribution. One is volume, another is surface, another is linear charge distribution. We did this in the last class. Okay, so if you have any doubts, you can actually ask me. Otherwise, we are towards the end of the session. A quick recap on the linear charge distribution. Linear charge distribution, in case of a linear charge distributions are basically for one dimension. Okay, in case there is a charge flowing in a wire or in a ring. Okay, then you use linear charge distribution. For linear charge distribution, we use the symbol. We use this Greek symbol lambda, and linear charge distribution is again given for a very small length that you're taking of a wire. What is the charge? Okay, what is the unit? Okay, charge per unit length. Per unit length that you're calculating, how many charges there. That's linear charge distribution. Now, if you go into two-dimensional space, then you get a surface charge distribution. So in surface charge distribution, think of a circle, right? Then you have an area coming into picture. Surface charge distribution is given by sigma, and surface charge distribution you use charge by charge per, in a given area, how much charge is there. If you take a rectangle, okay, for how many charges are there, okay, how many charges are there in this particular area, okay, charge per unit area is basically a surface charge distribution. Next comes volume charge distribution. Volume charge distribution is when you have a three-dimensional space. Okay, so volume charge distribution is given by rho. So in case, take a sphere, and the sphere has charges on its surface. Let's say you have a sphere, like something like a ball, and then you have charges spread out all throughout its surface. How do we find that? So what is the charge, total charge that is in that particular sphere, right? That is basically given by charge per unit volume. How much charge is there? So volume charge density of the entire sphere, you take a very small region and you're going to check in that particular region how many charges there. So in case this is a three-dimensional or three-dimension, so you get charge per unit volume. Okay, so the positive charges always have their field lines directed outwards. Negative charges always have their field lines directed inwards. Okay, and with that we are coming towards the end of the class. Once again, we are starting a plus batch for class 12. This is an ongoing batch, so the next plus batch is going to be from 1st June onwards. The course would be delivered in English. So for physics, we would be meeting every Monday, Wednesday, Thursday, Friday between 5:15 to 6:15 p.m. Math, Jyoti ma'am will be taking. Chemistry, Manisha ma'am will take, and biology, Lakshmi sir will be taking. Alright. So these this course that is starting on June 1st. This is in case a few classes if you had missed, you can always go back, see the class recordings, and in the doubt classes you can ask whatever whatever doubts you have regarding these topics. Okay. So the focus of this course is your midterm syllabus coverage. Okay, and it's an ongoing batch. Okay. And so this is an ongoing achievers batch. This will be a continuation of what the achievers batch was going on, and this is a new batch that is starting on 1st June onwards. Alright, and also as I said in the beginning of the class, do not forget, check out the Unacademy ANSAT. This is your Unacademy National Scholarship Admission Test. This is an offline test. It will be a computer-based test, but it will be an offline test in the centers that is happening. And this test is for IIT, JEE, NEET, UG, and class 9 and 10 foundational courses, right? If you want to take these foundational courses, if you're an aspirant for if you're an IIT, JEE, or NEET, UG aspirant, then you can take these courses. Okay, this test is going to be conducted across 40 cities, and the top 40 rankers will win an iPhone, and all the test takers gets an Unacademy T-shirt, the course. And also you can win up to 90% scholarship. Okay, so the percentage of scholarship you get will depend on how much percentage you're getting through this exams that you're going to take. Okay, now you can use the course to register for this course. You have to pay around 199 rupees, but if you're using my code MTIS10, you'll get a 10% discount. So somewhere around 169 rupees or 170 rupees you'll be paying, because you'll get a 10% discount on that 199 rupees. Okay, the last day for registration is basically June 6th. Now, we have the Unacademy community feature where you can follow any educator you like on the Unacademy community features, and you can share your feedback with the educators via polls, right? You can you do not have to miss any updates from your favorite educators. The link is also given below here. And Bucks Bounty is one more feature. In case if you watch any inappropriate content, and if you report them, you will get a prize for the same. And with us, we're coming towards the end of the class. Subscribe, press on the bell icon to subscribe to the channel so that you'll stay updated with the live classes that's going to come. And today evening also, we have one more class at 8 p.m. In that class, we would be discussing about electric lines of forces and basically dipole moments. And you like and share the video as well. Okay. So if you have any doubts, you can ask me in the chat box. Otherwise, I'll be ending the session now.